We're going to go ahead and begin our notes on areas of the circles as well as sectors. And we'll talk a little bit more about those sectors. Your circle area, this first page, is just going to be your pi r squared. This is something you've learned since possibly even elementary school. Okay. Now, this first problem, let's pay close attention to. On this target, each ring is spaced 2 inches apart. Okay, so each black area is 2 and each white area is 2 inches. The radius of the entire target is going to be 13. We will not be using that because they want to know what the area is of just the bullseye, right? We are going to find both exact area, which is also known as in terms of pi. We want the pi symbol in that, as well as the nearest tenth. Okay, so see that we're going to have 2 answers for this problem. Now, with our formula, I'm just going to rewrite it. We need to find the radius. The radius is not 13 because we just want the bullseye, that little tiny circle. Now, if each one of these black and white rings are 2 inches, we're going to see here counting backwards from, we've got 2, 4, 6, 8, 10, 12. So we need to remove 12. Now that leaves us 2 inches for this black bullseye. That is the diameter of the bullseye. So half of that 2, your radius is just going to end up being 1. So as we plug into our formula, area equals, we have pi, our radius of 1 squared. Now again, in terms of pi, we want to make sure that we leave our pi symbol in the answer, and 1 squared just comes out to 1. But just like with a variable, if we only have 1, we don't physically write that 1 there. So for this, when your area in terms of pi, and we have that radius squared as 1, we just leave it as pi, and your units are squared. So this is in terms of pi, or exact area. Sorry, I'm used to calling it in terms of pi. Now we want it round to the nearest tenth. All we have to do is plug in pi into the calculator. Well, pi in the calculator, we've learned in junior high, and that is 3.14, but we just want one number after the decimals. So the area is going to be approximately 3.1 inches squared when rounded to the nearest tenth. Rewind it if you need to see it again, please, especially with why we're using 1 for R. Right? Next, we're given the area. The area is, this is exact because it has the pi symbol, 196 pi. That is A. We are going to find the radius. So we have to work backwards. So using our formula of area equals pi r squared, we are plugging in for A, which is the 196. Please do not forget the pi symbol. Okay? And then over here on the right, we have pi r squared. Okay, please make sure you're seeing that radius is squared. Okay, sorry for the smudging. What we're going to do to get r by itself first is get rid of pi over here. So we're going to divide, since it's pi times radius squared, we're going to divide both sides by pi. So it's going to end up canceling on both sides. So over here on the left, we have 196. On the right, all we have is radius squared. Bring the exponent down. Because now your radius is not 196, your radius squared is 196. So as we've learned throughout the year, especially with Pythagorean theorem, to get rid of that exponent, we are going to take the square root. That will cancel the exponent, giving you r for radius, and the square root of 196 is a perfect square. It comes out to the total, whole number of 14. So your radius comes out to 14 inches. It is not area, so it's one-dimensional, just inches. The next problem, we're going to take a look at, now I'm giving you the circumference. We want the area. Okay, so here is circumference, and we are looking for exact area in terms of pi. Do not put pi in the calculator. We want the pi symbol in our answer. Let's start with the circumference. We need the radius. Okay, your formula for area is pi r squared. We're not using 30 pi in this formula here. So let's move to the side over here and work backwards. Because we want radius, I'm going to use the 2 pi r formula. Okay, circumference being 30 pi, I'm going to plug in 30 pi for C, and then our 2 pi R. With this, we can just get two birds with one stone, just get rid of the 2 and the pi at the same time, okay, by dividing by 2 pi on both sides. Oops, sorry. The pi's cancel on the left, the 2 and the pi cancel on the right. So all we have to do is take that 30 divided by 2 to get 15. Not our answer. Now we can go plug into our formula. Your area is going to equal pi times that 15 squared. Make sure that exponent is on the inside. Now, because we want this as exact area, okay, we're going to go ahead and take that pi symbol and we're going to move it down to where I'm going to put my answer. Okay? We want to leave pi in the answer. So then all you have to do now is plug in 15 squared into your calculator and place it in front of the pi symbol. 15 squared is 225. So our final answer, exact area, is going to be 225 pi. We're dealing with centimeters, so centimeters squared. Notice that pi symbol remains in our answer. Okay, the next page is on sector area. We need to understand a sector is an area bound by 2 radii. Radii is plural for radius, okay, and its arc. So if we look here at this little big old piece of pizza, that is a sector. And we're going to see that as the shaded area in the 3 problems below. Now, the original formula for sector area is over here as proportions. You're going to take the measure of the arc, which is the same as the central angle, over 360 equals the area of the sector, which is going to be our unknown, times the total area. So you'd have to go find the total area. Some of us have taken this proportion formula and we have done the cross multiplying and dividing to create a shorter formula right here, where all you have to do is plug in for theta and plug in for the radius and plug it into our calculator. So this is going to be the formula I will use. Other teachers do still use the proportion. So if you're not Katy High School and have Miss Collins as your geometry teacher, you may need to check because this may be the only formula that you're provided. Okay? And we're going to go ahead and put a reminder here that that theta symbol is your central angle. And we should already know R is going to be that radius. And let's take a look. Number 1, we are going to find the exact sector area, okay? And we're going to find it of the shaded area here. We go and lower it down so we can see our formula. So in our formula, we need theta and we need our radius. So our theta, find that central angle, 120 degrees, and your radius is given to you as 6. So then all we have to do is take this formula. We've got A equals. In the numerator, we're going to throw in pi, theta, which is 120, times your radius squared, 6 squared. Please make sure that that exponent is inside the parentheses with the 6. Do not forget to place this all over 360. You don't have to remember it's 360. It's in the formula right there for you. Now again, like with the area problem that we just worked on, number 3, we want exact. That means this pi symbol, and I'm going to go and move it up here, needs to be thrown down in our final answer. Okay, move that down here, and we will not be plugging pi into the calculator. So I'm going to go ahead and take a little bit of baby steps here, and we're going to take the 120 times 6 squared. We're going to get 4,320. Do not forget, bring down that pi symbol. I apologize for the smudging. All over 360. And the reason I'm not saying plug everything into the calculator all at once is because I don't want pi in the calculator. So take this little baby step of taking the central angle times the radius squared. And now all we're going to do in the calculator is plug 4,320 divided by or over 360. And this is going to give us 12. So your final answer, exact, is 12 pi. It is sector area. Area is squared. This one doesn't have inches or anything, so we'll just call it units squared. Rewind if you need to, please. Number 2, we're going to round to the nearest tenth. So we will be plugging pi into the calculator. We need to look here at theta, our central angle. We don't have it, but we've learned the central angle is the exact same measurement as its arc. So theta will be 20. We're given our radius of 3. So all we have to do is plug into that formula. Area equals pi times theta times radius squared. So pi theta of 20 radius squared all over 360. If you'd like to, you can plug everything into the calculator at once. Please be careful, make sure that exponent is with the 3. It is inside the parentheses. If we take the baby steps, it's less likely to type something in wrong. Here, we're going to wind up, sorry, like pi written last, 20 times 3 squared is going to give you 180 pi over 360. Pi needs to be in the numerator in your calculator if you're using the fraction function. To the nearest tenth, we are looking at one number after the decimal, 1, 0, and 10. And this will be approximately 1.6 units squared. Again, pause and rewind if you need to see it again. Okay, the last one, it is specifying we want the shaded sector. Look where the shaded sector is. It is the majority of the circle. Okay, and we will be rounding to the nearest 100. 100 has 2 zeros, so I want 2 numbers after the decimal. All right, let's first start off with we need theta. 65 is not the theta of the shaded sector. It is what's left over from the 360. We want everything else. We have to take this 360 all the way around, get rid of the 65 that's in the non-shaded area to get 295. That is going to be the theta that we're going to use. And then our radius they gave us as 11. So let's look at our formula here. We have, I'm not going to move it up and down anymore, but pi times the theta, we're using 295, times radius, 11 squared, in parentheses with the 11, all over 360. I'm going to go ahead and plugging in 295 times 11 squared into the calculator. I'm going to get a big number, 35,695. Don't forget your pi symbol. All over 360. All of that into the calculator at once. Please do not plug in 35,695 times pi. Round it and divide, okay? Let's keep it as close as possible. Plug that all into the calculator at once with a fraction function. We're going to get approximately 311.50. It was 49 something. I don't remember now, but they told us to bump that 49 up to a 50. And this we do have as inches. So we have inches squared. Again, if you do not have me as a teacher, please check with your teacher which formula they will provide you and which one they want you to use.